Let's go to Code Milkers. Today we got Bitwise and of numbers range. This question was new to me, so I had to do a lot of research on how to actually figure this question out. I don't have the most solid handle on it, but I can explain what I did. Since we have to look at these numbers in binary in order to limit the range, because once I read the question, you'll understand why we can't iterate over this from m to n. Given a range m through n, where 0 is less than or equal to m is less than or equal to n, and n is less than or equal to, where does that even end? Is it 2 billion? Yeah, 2,147,483,647. So that's like 10 to the power 9. That's way too big for us to think about looping from n to n successfully to find the bitwise and of the entire range. So what we can do instead is think about shifting bits to the left to find where the m and m have a common number. So if we look at the example of 5 and 7, 5 is 101 and 7 is 111. So if we shift each to the left by 1, we'll get 1, 0, 1, 1, still not equal, and then we get 1 and 1, so they're equal. And now we can, so then our count would be 2. So we had to shift two spaces in binary representation to find where they're equal or where m is no longer less than m. So once we find that, if we shift the amount of bits represented by count onto m, we find the bitwise and of the entire numbers range. So you can see the implementation right here. We simply initialize count, set it to 0. Then while n is greater than m, so they're not equal yet, we increment the count so we can eventually shift the left bits, and then we just reassign m and we reassign n to themselves shifted 1. So we can see what, I don't know if I can click on this right now. There we go. Okay. So the bitwise shift operator takes 2 operands. The first is a quantity to be shifted, and the second specifies the number of bit positions by which the first operand is shifted. So we shift it to the left by 1 each time. And then you can see here the console log. At the end, we've reached 1 and 2, so m is actually 1, and so is n at the end, so they're equal. And then we just shift 2, which gives us 4. Actually, let me get rid of that console log by slowing things down. Okay, accepted. Let's check out the speed. 98%, pretty fast. I'm going to think about this question more so I can explain a little better. But in the meantime, hope this helped. Have a good one. That was some prime